4/5 to the fourth or 0.8 to the fourth? How much? Give me 3 decimal places. 0.409. Okay. So you have roughly a 41% chance that none of them are correct. Because the probability of getting each one wrong was 4/5. You could have went to the other way, and you could have done 1 minus 1/5 raised to the fourth. But we'll take 4/5 to the fourth. That's the probability we get none right. And then the probability that we get all 4 right is going to be 1/5 raised to the fourth. So 1/5 to the fourth, yeah. Say it one more time. 0.0016. So that's a 0.2% chance that you get all of them right just by guessing. Now, dang it. And then you get 1 right. So the probability you get 1 right, and only 1 right. So we're going to get 1/5. That's our right vote. And we'll raise that to the first power. And then we get times 4/5 to the third power. Okay? The 1 and the 3 as the exponents are talking about our 4 questions. Our probability of getting one of them correct is a 1/5 probability. The probability of the next one being wrong, our 4/5 is the third. So on your calculator, 1/5 is 0.2. And then so you go 0.2 times, in parentheses, 4/5 raised to the third power. Yeah? 0.1024. So probability of you getting one of the problems right is about 10%. Okay? And then the probability you get 2 right. So this is going to be 1/5 raised to the second, 4/5 raised to the second. 0.0256. So 2.5% chance that you're going to get it. All right. So then I'm going to change this up a little bit. We're going to go to that big old binomial probability equation. Well, the C is the combination portion on your graph, right? So we're going to use this equation for the next couple problems, and this is what we're going to use from here on out. Now, the nice thing is I'm going to show you on the calculator how some of the stuff will work as well, which is a faster mode of doing it when you have many events that take place. But I want to know what the probability of getting 3 correct would be. And I'm going to use the NCR and the probability that it will happen times the probability it won't happen. So this equation. So getting 3 correct. How many questions do we have to choose from still? How many questions are still left on our test? There's 4. Which there's 5 outcomes each time. So I still have, I have 4 questions left that are blank. And I have 10 seconds, I gotta go A, B, C, D, or whatever. I wanna know I wanna get 3 correct, and then this is gonna be the probability of right. So what's the probability I get one of the questions right if there's 5 outcomes? 1/5. So what's the probability to get it wrong? Wrong. It's going to be 4/5. Do you agree with that? Okay. So I'm going to plug things into this. So it's going to be 4 choose 3 times 1/5 is the same thing as 0.2. How many questions? So the R right here is going to match that R. And the probability of wrong is 4/5, which is 0.8. So I want 3 of those questions to be right, 1 of them to be wrong. So using your calculator, go 4C3, get an answer. And the calculator will handle it pretty nicely. So this comes to what? Would you get the answer right there of? Just 4C3. 4. Okay? And then 0.2 to the 3rd power is going to give me 0.008. And then 0.8 to the 1st is 0.8. So if I multiply 4 times 0.008 times 0.8, I should get the answer. Okay, so you have a 2.56% chance of getting 3 questions correct of the last 4 questions if you just arbitrarily bubble in. Could it happen? Yeah. Will it happen? Statistically speaking, probably not. Now here's the tough thing. Play that lottery, right? The lottery's sales pitch towards you is we're going to, for this much money, you can win this much money. So you're willing to take a little bit of a gamble on giving the state $2 for a lottery ticket, or $5, link what you call it. But the return on that could be millions. If you win that Powerball, you might not have to work a day in your life, right? So a lot of people say, well, me losing the money for the possibility of you never having to work again might be worth it, right? Would people play Powerball if each ticket was $100? Probably not. So the state has to figure out what's a good value. It used to be $1 for Powerball, now it raised to $2. So it's twice as expensive. Still popular. Okay, I'd say not as many people are playing it, but I would say a good amount are playing, a better amount are playing it, paying $2 versus a lesser amount. Okay, you guys ever take E470? What do you notice when you're on E470? You have to pay. What else do you notice? Huh? Nobody's on it. So nobody is on E470. Why is that? Yeah, we're too cheap to pay. It's a voluntary tax for us to pay if you want to take it. Is E470 convenient? Well, yeah, if you need to get to the airport and you're supposed to be at the airport around 5:30, 225 is not a good option right around rush hour. But if you paid the money going through the tolls, you can cruise along at 80 miles an hour all the way to the airport. Is it worth it? I mean, what's your time worth? So, my opinion, I think E470 should drop their rate to include more people to be on it, but, you know, they know what they're doing, supposedly.
Did you know that they're making the road to Boulder?
It was a toll road.
So no, they're going to, it's going to be again.
Yeah, I know one to the thing. It's an inside lane. It's going to be a toll lane. It's not going to be the whole thing. Yeah, like on I-25 where it switches, and then every now and then there's some moron who doesn't realize the barricades that are down. You don't go this way.
Officer, I don't know what I was doing wrong.
Hey, it happens. All right, letter F. Letter F. So again, we're going to continue with this process. We're going to use that process. Shh. So I want to know what the probability of getting at least 1 one correct. Okay? So getting at least one means 1, 2, 3, 4, or 4 of them, right? So I could go this way if I wanted to. I could go the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. I could do that. Or what I could do is realize if I go 1 minus the probability of getting 0 of them right, it's going to give me the same answer. So each of these would be this equation. Okay? So if you were to do this 4 different times and add them together, or if I went 1 minus that one time, the 1 minus this one time is a lot less than these. So now we're trying to trick it. So I'm going to do the complement of getting at least one correct. And I'm going to find out, I'm going to figure out the probability of getting none of them correct is, and do the complement of it. And that'll give me the probability of me getting at least one right, which could be 1, 2, 3, or 4 of them correct. Okay? So, let's use this right here and plug it in. So I'm going to go 1 minus NCR. How many questions do I have left? There's 4. Choosing the probability we get none of them right. Okay? Times the probability of this event. So what's the chance that I get a problem wrong? 4/5, which is 0.8. 0.8 raised to the 0 power. What's the chance that I get one right? 1/5, which is 0.2. So I'm going to go 4 minus 0 because n minus r, n minus r, n minus r. 4 minus 0 is to the 4th power. So on the calculator, I'm going to go 1 minus. What does 4 choose 0? That's right. It's 1 or 4? 1. What is 0.8 raised to the 0 power? 1. What is 0.2 raised to the 4th power? So 0.2 times 0.2 times 0.2. Do it. Say it one more time. 0.0016. Okay. So 1 times 1 times 0.0016. This is going to become 1 minus 0.0016. What is 1 minus 0.0016? 0.99 what? Okay? That, what is the probability I get at least one correct? So it's the probability of getting 1 plus the probability of getting 2 plus the probability of getting 3 plus the probability of getting 4. I have a 99.84% chance of getting it right. So you're sitting there on that test. You have 4 questions left, you have 10 seconds left. You're gonna guess randomly. The probability of you getting at least one correct is 99.84%. So should you leave them blank? No, odds are in your favor. Do you know which answers are correct? A through E. How do I know which ones? I don't know. I'm going to do the best I can to take a shot in the dark. Do standardized tests realize that the last problems on a test are usually guessed quickly? I would say a standardized test, they're going to sit there and they're going to tell you, oh yeah, no, B is always your best choice to pick. But you know what those standardized tests probably would do? I know if I was making those standardized tests, you know what I would do? yeah, I would make sure B is not going to happen. Because I would realize the last handful of questions on the test are going to be guessed really fast. That's what I would think I would do as far as the test went. But, so I wouldn't necessarily bubble B, but don't take my testing advice. I'm just trying to tell you what I would do if I was making this test. All right, so that was letter F. Getting at least one correct. Okay, letter G. Letter G. We want to know what the probability of getting at most 2 correct. All right, English grammar folk. What does at most mean?
Like,
No more than?
more than 2.
I'm getting at most 2 correct. So what else could happen in this event?
Yeah,
one.
1. What else could I get?
0.
0. So this is the probability of 0 plus the probability of 1 plus the probability of 2. So probability of 0 plus probability of 1 plus the probability of 2. There's not really a shorter way to do this because we're flat smack in the middle of our probabilities or our number of questions. Okay? So, I'm going to use my equation, NCR times Q raised to the R times, or that's P raised to the R, excuse me, times Q raised to the N minus R. I have to use this equation how many times in this event? 3 times. Okay? So I have how many questions left? I have 4. So 4C 0 times the probability of getting a correct answer. Probability of 5 choices is 1 out of 5, which is 0.2. Okay? This is going to raise up here. So if it's a 0.2 chance of getting it right, it's a 0.8 chance of getting it wrong. And that'll be raised to the 4th power because it'll be 4 minus 0. Plus 4 choose 1. Probability of getting it right. That 1's going to match here. Times the probability of it not. How many questions are left if this one's right? 3. Plus our last one. 4 choose 2. Times the probability of getting it right. What am I going to raise this one to? 2. What am I going to raise this one to?
2.
Because I have 4 total questions. Okay? So we've already done some of this. What is 4 choose 1? Or excuse me, 4 choose 0?
1.
1. What is 0.2 raised to the 0 power? 1. What is 0.8 raised to the 4th power?
0.4096.
Say that one more time.
0.4096.
0.4096. Okay? We've taken care of this portion. Okay, what is 4 choose 1? 4 choose 1 is 4. What is 0.2 to the 1st power? 0.2. What is 0.8 to the 3rd power?
The same thing?
0.8 raised to the 3rd power.
Yeah, I got the same.
0.512.
0.512. Plus this one. Let's see. What is 4 choose 2? Is it 6? Okay. 0.2 times 0.2 is 0.04. 0.8 times 0.8 is 0.64. So I need this, and this, and this added together. So on your calculator, go 1 times 1 times 0.496 plus 4 times 0.2 times 0.512 plus 6 times 0.04 times 0.64. 0.9728. Can we get a second on that? Getting at most correct. 97% over 97% probability that you get at most 2 correct. Still sound like it's pretty good? I like it. I like it. So this formula is utilized over and over and over again. And if you understand the verbiage that's being given to you, it's going to be easier. But there's times that statistics, they throw the literal meaning of the word at you. So if you suck at English, it's really tough to get through. Even if you're good at English, it's really tough to get through these. Okay, because you're going, okay, what does that really mean? Remember when you first became a teenager? And you thought you knew anything? And you tell your parents, no, you said. Remember that?
No.
You never did that? No, you said I need to put out the trash. You didn't say when. It's not my fault the trash guy came on time on Monday. You said put out the trash. You didn't say when though. Parents like, oh, okay, now I have to play this game with my kid. Give me your phone. Just give me your phone. You don't get any phone. You guys don't remember that? Maybe I was the only one that played lawyer with mom and dad. All right, letter H. Letter H. What is the probability of getting...
Wait, did you have a phone back then?
Yeah, it was connected to the wall. But I was spoiled. I had my own phone number. It rang just in my room. Yeah.
But they would take it in and just
Yeah, they just take the whole phone system. I was, man. I was spoiled, Brad, as a kid. Man, it was bad.
Were you on the trial?
Was I in the what?
On the trial?
No, not really.
Were you the oldest or youngest?
Oldest.
Oh.
My sister's more spoiled than I, but I was pretty spoiled. Yeah, it was good.
Yeah.
It was good. All right, we want the probability of getting a 1 or 3 correct. I don't care about the 2. I want to know the probability of me getting 1 of these questions right or the probability of me getting 3 of them right. I'm not worried about the none, the 2, or the 4. So I want to know the probability of getting 1, and I'm going to add that to the probability of getting 3. So I want to know the probability that in this last 10 seconds on this test, I'm going to arbitrarily bubble one of these 5 choices for these next 4 questions. What's the probability to get 1 of them right, or what's the probability to get 3 of them right? Okay? Guess which equation we're going to. We're going to do NCR, sheesh, times the probability of the event happening times the probability of the event not happening. How many times am I going to use this problem?
Every time.
How many outcomes are up there?
Oh, 2.
All 2. Yeah, every time. No, twice. All right, you ready? So I have 4 choose what? 1. The probability of me getting a question right is what? 0.2. It's 1 out of 5, which is 0.2. I'm going to raise that 0.2 to what power? 1. The probability of me getting them wrong is 0.8 or 4/5. What am I going to raise that to? The third. Why is it the third? Because these two events have to add up to the number of questions left. I'm then going to add that to 4 choose what? 3. We're skipping over the 2. We don't worry about the 2. So then I'm going to do the probability of getting it right, which is 1/5, which is 0.2. What am I going to raise that to? The third. What's the next number going to be? 0.8, which is 4/5. Probability of getting it wrong. What's this going to be raised to? First. 1 and 3 have to add up together to give me those events. So 4 choose 1. Help me out. We've done it, but I can't remember what it is. The whole answer?
That's 0.4096.
What is?
The whole thing?
No, what? You just yelled out an answer.
Yeah, that's what that whole first one is.
This right here
Yeah.
comes to what?
0.406. 0.4096. 9.6.
9.6. Because we had worked that out already, right?
Yeah.
Perfect. Did we do 4 choose 3? Do we know what this is yet?
0.0256.
So you worked out the whole thing?
Yep.
Point what?
02.
0.256. Okay, add those together. 0.4.
4.352.
So, 10 seconds left. What's the chance we get 1 or 3 right? 43.5%. Is it worth doing? Is it worth trying? You got a chance, you might as well. If it doesn't count against you to guess, might as well. Don't let it be that SAT problem where you get 1 point for leaving it blank, 0 points, I don't forget what the rubric is, but that's basically what happens.
To lose points for guessing on the SAT, but you get points for guessing on the ACT. But
Guessing doesn't count against you on the ACT, but on the SAT it does. So if you can't eliminate it down to like 2 choices, leave it blank. That's the theory behind it.
Have you not taken the SATs?
I took the ACT, but I'm going on the West Coast.
Oh.
All right. All right. Can I move on? Can I move on? You follow what we're doing? It's recorded for a reason, so I think I'll have time to go through example 1 and it'll give you a pretty good idea. Example 1, which one do you want to do? Example 1 or 2?
Which one's hard?
I think they're about the same. Why 2?
I like number 2.
Why? Tell me why.
The greater than.
Tell me why, Mr. Phone on Best Boy.
My baseball number is 22, so I like 2, so let's just do 2.
But I like 21.
I can tell you that Hayden and Caesar probably like number 2.
Yeah, they like number 2 too.
Why buy?
Basketball.
It's basketball. So, number 3? I don't think I have number 3. All right, let's do the basketball example. It should help us out. Example number 2. It talks about, it says a basketball player typically makes 82% of his free throws. Talking Hayden's free throws here. Caesar's at 100%. Right? I'll give you guys each like an A on the next quiz if you're at free throw line and do the granny. I'm just kidding. I can see Brooker just ripping it, and then you're like, Stroke told me, and then he'd come over and kill me. I'd love it. All right, a basketball player typically makes 82% of his free throws. So if he makes 82%, what's the probability he doesn't make them? Almost 18%. So 18% aren't made. He shoots 8 times, assuming each throw is independent fine. The probability that he makes 5 of the 8 shots. Probability of making 5 of the 8 shots. Okay? We're going to go back to this equation because we're going to use it over and over. So we're going to use that. So, are we worried about that he makes at least, at most?
No.
No, we just want to know, this person got a shot of making 5 out of 8 shots. Okay? So, I'm going to use this equation. I'm going to go 8C what? 5? What is the probability this person makes the shots? Point what? 0.82. What is this going to be raised to? The 5th. What's the probability of not making the shot? 0.18. 0.82 plus 0.18 is 1.0, right? What am I going to raise 0.18 to? The 3rd. Okay, 8 choose 5. Calculator time. 56? What is 0.82 to the fifth power? 4 decimals, please.
0.3707.
0.3707? What is 0.18 to the third power? 4 decimals, please.
0.1210.
0.1210? Multiply it. 56 times 0.3707 plus 0.1210.
You gave me the wrong number.
Oh, which one's wrong?
They gave you the answer.
You gave me the answer? So what's this answer?
Well, the whole thing is
That's the
12%.
whole answer.
That's the whole entire answer.
Yeah.
So what should this have been?
That's 0.0058.
0.0058. What do you think? Is this 85% basketball player looking pretty good? A 5 out of 8 free throws? What's the chance that this basketball player makes 5 out of 8? 12%. Does that mean this person isn't a good basketball player? No, we're looking at the exact probability. It was like, okay, I know I got 82% shooter out there. And I'm hoping this guy gets to the line 4 times in the double bonus. Double bonus gets you 2 shots, right? Just want to make sure. Am I speaking that right? Double bonus, 2 shots no matter what? Unless is it a 3-point? You get 3? Come on, you guys play!
No, double bonus is just 2.
2 shots no matter what.
No matter what.
Okay. So you're in the double bonus. You got a guy in the game. You're hoping he gets fouled 4 times, because that puts him at the line 4 times for 2 shots each time. And you're like, okay, I need this guy out there to get 5 out of the 8 shots. And I get you. You know, there's not a basketball coach out there going, all right, I'm putting him in because he's going to do this. Now, you might put the higher percent free throw shooter in, especially towards the end of the game when a little bit more fouls might be taking place. Because you don't want, the Shaquille O'Neal had like a 13% average his first year in the NBA. Standing at the line going, oh, went over the top. Okay? So, this guy, this 82% free throw shooter, the probability he gets 5 out of 8 shots. I don't care about any of the other shots. I just want to know what the probability of getting 5 out of 8 is. 12.10%. Okay? B. What is the probability that he makes 2 of the shots? Makes 2 shots. Is this the same kind of problem? If I go back, it says 5 out of 8 shots. This one says makes 2 shots. Does it mean the same thing or no? What's probability to make 2 shots? What's probability to make 5 out of the 8? I think it's the same thing. Okay? So, I'm going to again use my equation. NCR times the probability of the event taking place times the probability of the event not taking place. Okay? So again, this is our favorite equation. How many shots are left in this game? So I have 8. Choose how many? 2. Times the probability makes 0.82 raised to what? Second. Probability doesn't make? 0.18 raised to the what? 6. Has the 6. 6 and 2 have to add up to all of our events. Okay, help me out.
It's like a negative times 10 thing.
Oh, okay, well let's go 8 choose 2 first.
28.
28, exactly? Or 20, okay. It should be exactly. 0.82 to the second, so 0.82 times 0.82.
0.672.
0.672. Oh, hey guys and girls, do me a favor. Will you try and do 1 through 5 on the next worksheet, and then we'll work through the rest of it come Monday.